Hello friends, in this video we'll understand the derivation of the derangement formula. The derangement formula says that if there are n elements and all those elements have to be deranged. Deranged means none of the elements are at its correct place. Okay, not even one element is at the correct place. Okay, the number of ways it can be done is given by n factorial into 1 minus 1 upon n factorial plus 1 upon 2 factorial minus 1 upon 3 factorial so on till minus 1 raised to n upon n factorial. Okay, so this is the number of ways n things can be deranged. Deranged means none of the element is at its correct place. So 0 elements is at its correct place. Then it is a derangement. Okay, so now to derive this formula, let us say I have n things. Okay, total number of ways they can be arranged. Total number of ways n things can be arranged. Total ways will be equal to n factorial. Total number of ways n things can be arranged is n factorial. Okay, now suppose let us say I pick one element, okay, and I put it at its correct place. Okay, rest other elements can arrange accordingly, okay, as it is, but one of the element is at its correct place. Okay, so the total number of ways for that will be, so if I have one element correct, that means one element is at its correct place. Now out of n elements, any of the elements I can choose. So the number of ways to choose one element out of n element is nc1. Then the remaining n minus 1 element can arrange themselves. So into n minus 1 factorial. Okay, so if I apply the formula of nc1, it becomes n factorial upon 1 factorial into n minus 1 factorial. Now this whole thing is multiplied by n minus 1 factorial. N minus 1 factorial, n minus 1 factorial goes. So I am left with just n factorial. N factorial upon 1 factorial. Okay, so I'll just write it as then n factorial by 1 factorial. Okay, so it is n factorial upon 1 factorial. Okay, now if I have two elements that I have placed at their correct places. So two elements are placed in a correct place. Rest n minus 2 elements can arrange themselves. So if two elements are placed correctly, first of all I have to choose those two elements. So the two elements can be chosen into nc2 ways multiplied by n minus 2 factorial for the remaining n minus 2 elements. Now if I apply the formula of nc2, I get n factorial upon 2 factorial into n minus 2 factorial. Okay, this whole thing is multiplied by n minus 2 factorial. So n minus 2 factorial, n minus 2 factorial crosses out. I am left with n factorial by 2 factorial. Okay, so if two elements are at correct place, the number of ways they can be rearranged is n factorial by 2 factorial ways. So I'm going to write that over here. So if two elements are placed correctly, the number of possible arrangements are n factorial upon 2 factorial. Now similarly, if I have, let's say, three elements placed correctly, okay, then it should be nc3 multiplied by n minus 3 factorial, because three elements out of n elements can be chosen in nc3 ways. Those are placed at the correct places. The remaining n minus 3 elements can arrange themselves. So it will be nc3 into n minus 3 factorial. If you solve for this, you will get n factorial by 3 factorial. Okay, looking at the pattern. So it will be n factorial upon 3 factorial. Similarly, if there are 4 elements correctly placed, then it will be n factorial by 4 factorial. If 5 elements are correctly placed, it will be n factorial by 5 factorial. Similarly, so this will go on. So if n elements are correctly placed, okay, if n elements are correctly placed, then it should be n factorial upon n factorial. Okay, so now what we are getting is total number of ways to arrange n elements is n factorial. But if I place one of the elements at its correct place, the number of ways the arrangement can happen is n factorial upon 1 factorial. Now if I place two elements at a correct place, then the number of possible arrangement is n factorial by 2 factorial. If three elements are placed correctly, then it should be n factorial by 3 factorial. Similarly, if n elements are placed correctly, the number of possible ways are n factorial by n factorial. Okay, this is what we know. Okay, now if you look at it, derangement will be total ways, then I have to deduct the number of ways wherein arrangements happen wherein at least one of the elements is at the correct place. I have to do that. Okay, so now total ways is n factorial. Now if I deduct wherein one element is at the correct place, because in derangement no element is at correct place, and this total ways include cases wherein one element is at correct place and none of the elements are also at correct place. Okay, so n factorial, then I will subtract n factorial, or I will just write n factorial upon 1 factorial. Okay, now if you look at it, if one element is at correct place, n factorial upon 1 factorial, this it will include cases wherein two elements are also at correct place, because one element is at correct place, but and that is n factorial by 1 factorial is the total number of arrangement when one of them is at correct place, but it will include cases wherein at least another one of them is also at correct place, because out of n minus 1 elements, some elements might come at their correct place in total number of arrangements. So when one element is at correct place, it includes cases wherein two elements are also at correct place. Okay, so I have deducted this, so I will have to add this back, the two elements at correct place. So this will become plus n factorial upon 2 factorial. Okay, now similarly now I have to deduct 3 elements which are at the correct place. Okay, because I have added it back through n factorial by 2 factorial, because n factorial by 2 factorial will not only have 2 elements at its correct place, but will also add 3 elements at its correct place. Okay, so I have to deduct that, so it will be n factorial by 3 factorial. So if you look at it, alternate negative positive are coming. If I follow this pattern, then it should be n factorial by 4 factorial and so on till minus 1 raised to n upon n factorial. This is how it should be. Now if I take n factorial out from it, what I will get is this formula. If I take n factorial common, what I will get is n factorial into 1 minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial, so on till minus 1 raised to n upon n factorial, which is the same formula here. Okay, so this is how the derangement formula is derived. Okay, it is a bit tricky. If you understand it, it is well and good. If you're not able to understand it completely, at least know the formula and apply it in the manner it should be applied. Okay, thanks a lot for watching this video.